I think today's lesson is the easiest one in the book. This is one of my favorites because we're just looking at lines and rotational symmetry. Everything today is about symmetry. So, many figures are drawn so that a line can divide them into exactly two equal overlapping parts. If you would fold them like a piece of paper, they would overlap and line up completely. A plane figure, or planar is what it should say, a planar figure. You don't have to write this down, planar. Or two-dimensional figure can have line symmetry. So what we're looking at first, the first part of this lesson is going to be on line symmetry, also called reflection symmetry. Because what we're going to be drawing are the lines of reflection inside the shapes. So that if it were a piece of paper and you would fold it up, everything would match up perfectly. You ever do that with a piece of, you're down to one piece of bread and you want a peanut butter and jelly? Yeah. So you do half peanut butter, half jelly and fold it in half. Yeah. That's line symmetry. Don't look at me like I'm nuts. You're going to remember that next time you have to do that. Next time you make a peanut butter and jelly sandwich with one piece of bread, you'll be like, oh, Mr. Bfoutty talked about this. This is line symmetry. And you'll be like, darn that guy, sneaking the math in when I'm at home. All right. Some figures have one line of symmetry. Some figures have many. Some will have none. That's right. So, here we have, right now, we have the arrow and an X. Let's first look at the arrow. How many lines of symmetry do you suppose this arrow has? Well, where would it be? Down the center vertically, correct? Well, can you find another one? If somebody can find another one, come on up and draw it. Go ahead. Question. Try it. If I fold it, will it fold up and over? No, they'll be perfectly line up. It won't work. Very good. That now the whole idea is.
You won't have the arrow on the bottom.
Very good. We have good discussion. Yes. This is the only one because what you want to do is like if this were a piece of paper, you want to fold it right along this red line and everything line up. So yes, the arrow only has one. How about this X? How many does this X have? Many. Okay, can you be a little more specific for me? Infinite? No. No, actually. Okay, so which horizontal, right? There's going to be one right here. Down would be vertically. Yes, vertically. Any others? Diagonal? Actually, yes. That will line up, which means it has to also go diagonally the other way. Good. So how many lines of symmetry did we have here? 4. So we have 4 lines here, 1 line on that one. Good. It has 4 lines of symmetry, and those are it. Okay, we now have a, bless you, we now have a square. We now have a square. We want to figure that out. Go ahead and draw the square and the hexagon. That's all right. It's okay. Just freehand it. However, you can put them, if you can fit all 4 on the same page, that's fine. Huh? Okay, we can go back at the end. Not a problem. Draw these 2 quickly. Okay, anybody want to come up and draw a line of symmetry? Okay, Andrew, I saw your hand first. Go ahead. Give me one. Brittany, you can give me the next one. Just any one you want. You just pick one. Nope. Use the line tool. It's easier. I had it picked. Now just push your finger up there and drag it down. All right, the first one is the vertical one. Okay, Brittany, come on up. You stink at it. Okay, go ahead. Give me another one. Horizontally. All right, Sarah, you want to give me another one? Did you see another one there? Come on down. You're next on Family Feud. Or Price is Right, whatever. Where would the next one be? Excellente. Ben? Did you? There are plenty of shapes here. Just relax. Very good. Yeah? I'm sorry? There are 4 lines there. Any others? Any other lines of symmetry there? No. So there are how many lines of symmetry for this one? 4. 4 lines of symmetry. Yes, ma'am. Amanda, what's your question? No. You can draw them just solid lines. I just do it just to show. Yeah, you don't have to draw dashed lines. I do not expect that. Right, Tim? That's it. All right, the hexagon. Jennifer, I'll even give you the fuchsia pink one. Give me one. Give me 2. Good, there's 1. That's it. That's good. There's 1. Give me another one. All right, there's 2. Yes, there are. Anybody else want to come up? Amanda, come on. You got it. Give me another one. There we go. Very good. Thank you, Amanda. Any others?
Yeah, because look at his face. Yeah.
Not a lot.
I see it.
Go. Yes. Do one of them. Aha! Very good. Andrew, go. You're on fire today, kid. And of course, it's the one opposite Jennifer just drew. There are 6. 6 for the hexagon. What we did is essentially we're cutting. If you get rid of the diagonal ones, which I will right now, and I'll bring them back in just a second, so relax. If I get rid of those going through the axes, what do we do in each one of these? We took and cut it in half each time. That's all we did. And that's all we're doing here. We did half through each one. Yes, ma'am. So you think that is what we would call mathematically an algorithm. A rule that always works. The number of sides is equivalent to the number of lines of symmetry. That is your conjecture, right? Okay. No, that's excellent. That's excellent thinking. That's good mathematical thinking to try and draw a correlation there. Very good. 6. Let's see if her pattern holds up. That's what she said. How many lines does that have? This is a what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's a 12 gone. Yeah. So, but these are what kind of figures? Convex or concave? These are concave. That's concave. So maybe you're talking about convex ones. All the convex shapes. That's a good conjecture. For all the convex shapes, the number, we'll see. We'll see if it bears out. All right, how about that check mark? How many lines of symmetry there? That is correct. None. None. Oh, man. We actually have to have a discussion on this one, don't we?
There's one.
Where is the 1?
Right in the middle.
So we have 1 going vertically. You are correct. Do we have any others? Very good, Jordan. There's 1 going that way. Which means there's 1 going this way. Which means there's 1 going this way. That's just my star isn't very good. A star has 5. 5 lines of symmetry. That star has 5 lines of symmetry. They're your notes. They're your notes. Don't be that precise. Just draw a star and put 5 lines. Yes, there are 5 points. Actually, there's 10. Because you also have to include the ones where they cave in. There are 5 external vertices and 5 that are moving more towards internal. I knew what you meant. But this is a decagon, but it's also concave. It's not convex. So I would say your algorithm's correct. That if you have a concave polygon, the number of lines of symmetry will be equivalent to the number of sides or vertices. Because the pentagon's going to have 5, and we're not done. This is half of it. So far, so good? Okay. How about this one? How would I draw this? Anybody want to come up and draw this and complete the figure so that that blue line will be the line of symmetry? Amanda, come on up. Sure, yes. I'll grab it and bring it down for you. Perhaps I will. There you go. Just use the black pen. Yeah, go ahead. You're good to go. You're right. There's going to be a triangle in there. You want to try? Come on up. Now remember, a line of reflection means I want to flip it across that line. So what happens to the rectangle? Right? This is the line of reflection. I drew it for you. So this one has to go, and this one has to go. There you go. So remember, this has to be 2 equal shapes that if I would fold up. So like that, like that. You would have been right then. That's what that one looks like. And is that, if you fold it up, won't everything or fold it down, won't everything line up? It will. Because that is, remember, that line of reflection is right in the middle, 2 equal images. 2 equal images that are like backwards to one another, just like when we were doing reflecting. The other thing we're going to do is rotational symmetry. Sometimes figures don't have lines of symmetry like this one. However, if it's rotated about a fixed point in the middle, so that it fits exactly over the original position more than once during a complete turn, it has rotational symmetry. And when something has rotational symmetry, we talk about it having an order of rotational symmetry. So if something has rotational symmetry, what we do is we find a point in the middle, and we're going to spin it 360 degrees. And we'll see how many times it lines up with itself in the full 360 degree turn. That's what we're looking for. How many times does it line up with itself when we spin it full 360 degrees? Yes, sir. Question? Statement? How many? You want to make a conjecture as to how many, what the order of rotational symmetry is for this? What is your conjecture? What's your guess? 2. Andrew guesses 2 is the order of rotational symmetry. I can actually show you exactly through the wonder of modern technology. We're going to clone this. So we have 2 that are exactly identical, right? I'm going to number my paddles. This is paddle 1 and this is paddle 2 on the overlapping shape. I'm now going to take this, draw the shape. Yeah, don't worry about the words so much, about the shape. Now I'm going to take this copy and put it over the original and line it up. Now what Andrew said is when I spin this 360 degrees, it's going to line up 2 times. Is he right or is he wrong? We'll make a guess. He did. Who thinks he's right? Who thinks he's wrong? Who doesn't know? Who doesn't care? All right, I'm going to rotate this. 1, 2. So he was right. How many times does it line up with itself? In the 360 degrees I spun it, it lined up twice. That's the advantage. That's the advantage of the technology. It really gives you a visual as to, wow, that's how it works. I know, isn't it great? I love this. Yeah, it should be. All right, how about these? Let's look at this propeller of this plane. Take a guess. How many times would that propeller line up with itself in one 360 degree turn? 3 times. How'd you get that? Very good. There are 3 paddles, 3 blades. So when it spins from there to there, it's going to line up once. There to there, it'll line up twice. There to there, it'll line up 3 times. So it's the number of times the pattern repeats itself. So what would be the order of rotational symmetry of this goofy thing that's similar? 5. Yes, Ben. Huh? How many times will that line up with itself? 5 times. Just like a circular saw with the 100 teeth. 100 times. You got it, Ben. Because those, on a circular saw, the teeth are all identical, and in one rotation, it lines up each time. It moves 1/100th of the circle, which would be 3.6 degrees. It'll line up. How about the large wheel of a steamroller? What's a steamroller? That's the stuff that flattens the asphalt when you're 1. There's no pattern. It'll always line up, won't it? There's an infinite number. That's the big thing that flattens the asphalt when they do a new road, when they put down the big wheel, yeah, the big cylinder, yeah. Same thing with the pop can. If you look at the bottom of a pop can, if you roll it, how many times does it line up? It continuously lines up, right? Infinite. That means infinite. There's an infinite number for those. Now, if we were looking at the pop side of the pop can with the opening and the tab, what would that have? 1. But if there's no design on it at all, it's infinite, because you're just looking at how many times you can spin a circle. One to 14, 18, 19, and then if you want to do number 30, it's for bonus.